Hello and Assalamualaikum to Miss Natasha. My name is NURUL IZZATI with the matrix number of 2075558, and my friend NURBALQIS FAALIHAH will be presenting about food irradiation. First and foremost, we need to know what is the definition of food irradiation. Food irradiation is a chemical process that exposes food to ionizing radiation such as gamma rays, electron beam, and X-ray without having any physical contact with the food product. This action kills insects, mold, and microorganisms, thus results in extending the shelf life and reduces spoilage of food. I will be explaining about the mechanisms of gamma rays in food preservation. The most common source of ionizing energy is cobalt-60. This radioactive material is contained in two sealed stainless steel tubes. These are placed in a rack, and the entire rack is immersed in a water chamber underground when not in use. When irradiation takes place, the rack is raised. Packaged food products move along the conveyor belt and enter an inner room where they are exposed to the rack containing source pencils. Energy in the form of gamma rays, or can also be called protons, pass through the encapsulation and treat the food. It also breaks the chemical bonds of food, similar with other food preservation. Unfortunately, small number of molecules are left and safe to be consumed in order to ensure the customer's safety. Gamma rays are measured in units called rods, and you should know different food composition requires different amount of gamma rays. Lastly, water, which has the property of non-reactive compound, will be used to shield cobalt-60 when it is not in use. As you can see in the slide, as soon as the gamma rays penetrates the food product, the bacteria and the microorganisms inside the food dies. Moving on to the next slide, is there any nutrient changes in irradiated food? Research has been found that low doses irradiation does not have any effect on foods. It should be safely consumed by human. However, high dose radiation can cause a slight change in the food nutrition. Food components are divided into two, which are macronutrient and micronutrient. Both of these food components were affected differently based on different factors that plays a significant role in changing the food nutritional composition. The first one is radiation dose. As we all know, low doses do not really change the nutrient of the food, but high doses radiation does. So it depends on the type of food whether what kind of doses would be better in food preservation. Same goes to the constituent of the irradiated food. Next, type of packaging. Each food product requires a specialized packaging based on the properties. As an example, legumes are usually packed using vacuum to remove air particles that could trap in the packaging, so it surely needs a different doses of radiation. Lastly, temperature and oxygen saturation would also chemically affect the nutritional composition. I will be passing the presentation to the next presenter, NURBALQIS FAALIHAH.
Thank you, Aqilah, for passing the mic. Now I'm going to talk about the electron beam accelerator, in which one of the ways to radiate food for preservation other than the gamma rays. What is electron beam accelerator or electron beam irradiation? It is a novel, non-thermal, and physical methods of food preservation technology. And as Aqilah mentioned before, food radiation in all sort of any wave aims to kill insects or any pathogens microorganisms to extend a product's shelf life, in which for electron beam irradiation, it is applicable to package or seal products while being safe and effective that does not cause any radiations towards the consumers, which is us humans. So as you can see here, this is the schematic diagram of electron beam accelerator that is used for food radiation. Now moving on, the focus is on the extended sites after the scan horn. For A, it is the X-radiation or X-ray as shown on diagram above, as it radiates different waves after the electron beam approach a target. While at B, it is known as electron beam or E-beam, as it will directly approach from output products from the electron beam accelerator machine. For E-beam, it is on high speed of velocity but is low in capacity on its releases, which resulting in short treatment of time with high dose rate thanks to the velocity. The food products will absorb the electron energy and damaging the DNA of the pathogens in the cell, thus destroying the abilities or capabilities of the microorganisms to reproduce. And this will halt all the activities of the microorganisms before it spoils the food. On the closer look for X-ray, as I mentioned before, the electron from E-beam is converted after it reaches a certain target of shield, which we usually use the tantalum shields, as the wave can penetrate the block of substances in which tantalum substances really well. This wave can penetrate the products way deeper than the unaltered E-beam, that resulting in high depth penetration with a good dose of it on a uniform ratio. However, even though the penetration exceeds the normal E-beam, it is less effective as the X-ray wave is not strong enough after colliding its particles with the tantalum shield. In short, food irradiation is a form of food safety to ensure a higher quality of food products for us as consumers. However, do remember that this technology is still on limited applications, as it is relatively still considered as expensive in the industry, while being effective on normal microorganisms, pathogens, and not viruses. That's all from us, Akilah and Balkis. Thank you for listening and have a good day.